Hi there is a lot of weird stuff in space. There's black holes, there's giant cigar-shaped asteroids from another solar system tumbling through space forever lost. There's a hexagon on Saturn. That's really weird. But today I'm going to talk about Thorne ytkow objects, or hybrid stars. Thorne ytkow objects, TZOs, consist of a red giant or red supergiant, which is, those are two types of large, relatively cool stars, with a neutron star, which is the size of Earth but weighs more than the sun, super dense, has a pure neutron core. Inside of it, it's a star within a star. Popular artwork tends to show these TZOs as, there's a red giant, and then right inside you see the neutron star. But actually, the neutron star is way, 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 way smaller than the red giant. So it's tiny, tiny. The existence of these hybrid stars was first hypothesized by theoretical physicist Kip Thorne and astrophysicist Anna Żytkow in their 1977 paper, Stars with Degenerate Neutron Cores. Thorne-Żytkow objects are usually, probably, created through the collision of a red giant, or red supergiant, and a neutron star. So, red giant or red supergiant is huge, neutron star is tiny, but very heavy. They crash into each other neutron star because it's so dense, it sinks right to the bottom or center of the larger star and takes up its place as the core. Telling the difference between a TZO and an ordinary red giant or red supergiant is tough because a TZO is an ordinary red giant or red supergiant, except that it has a second star inside itself. But the difference can be detected. We got to look at gravitational waves and spectral emissions. TZOs have very powerful stellar winds. They produce gravitational waves, and they contain more lithium metal than an ordinary red giant or red supergiant. Stellar wind is the emission of charged particles from a star. Our sun has a stellar wind, we call it solar wind, and it causes auroras when it interacts with our upper atmosphere. A TZO will have a very strong stellar wind because of weird magnetic stuff in its core near the neutron star. Gravitational waves are waves in space-time that they kind of act like three-dimensional versions of normal waves. So just imagine something heavy moving through water and causing ripples. And that's basically what neutron stars do. They're heavy, so they cause gravitational waves. A TZO has a gravitational wave signature pretty similar to a normal neutron star because it's a normal neutron star surrounded by a red supergiant or red giant, which doesn't make much of an impact in that way. A star's spectral emissions are light that it emits that we can use to tell what kind of elements are within it. That's how we discovered helium in the sun. That was the first place we ever discovered helium. Now we use it in balloons. A TZO is predicted to contain more lithium, more copper, and more zinc than a normal red giant or red supergiant. We actually haven't confirmed a TZO sighting yet. There's some stars that we think maybe there used to be, two very strong candidates, and then we found one of them was too light, and one of them, there was nothing really TZO about it after all. But we're still looking for them, so hopefully we'll find some. There's lots of very weird stars that we don't know about in the universe. So over time, we think that a TZO may eventually collapse into an ordinary neutron star with an accretion disk, which is a big spinning disk of stuff orbiting around an immensely heavy object in space, most famously a black hole, but it can also form around neutron stars. What's more, this hypothesis has explanatory power. Our universe is full of objects fitting this approximate description. Pulsars, which are neutron stars that spin really fast and they have magnetic fields more than 100 million times more powerful than Earth's magnetic field, sometimes have accretion disks. And sometimes those pulsars with accretion disks are isolated from anything else to draw in. So the question is, where's that mass for the accretion disk? Where'd it come from? And in this case, it would come from the outer layers of the red giant, which then were drawn into the neutron star. So yeah, Thorne-Żytkow objects are a fascinating model of star. And the idea that there'd be a star within a star is just, that's so cool to me. And neutron stars are super fascinating to me because they're so weird. And yeah, so yeah, do with this information what you will. I recommend, in the words of one experienced astronaut, keep looking up.